Hello everyone, welcome to Antennas and Microwave Engineering lecture series. Today I'm going to explain about m-derived filter, which is the continuation of the image parameter method, and we will discuss the MCQ questions also. Okay, so we will go to first MCQ question. The question is m-derived filter section is a modification of which method? Okay, the options are image parameter method, insertion loss method, constant K filter section method, and Richard transformation. And I already told you it's a derivative version of which one? The constant K filter section model. So the answer is constant K filter section method. Now the second question is, given a m-derived low pass filter has cutoff frequency 1 kHz, design impedance of 400 ohm and the resonant frequency of 1100 Hz, find the value of K. Okay, the options are 400, 1000, 1100 and 2100. These are the option provided. Now see the question. In the question, cutoff frequency. Cutoff frequency means what? FC, which is equal to 1 kHz in the question provided. And design impedance means what? R0. R0 equal to what? 400 ohm. And the resonant frequency of 1100 Hz, அதாவது F infinitive or FR, like that we can tell. Resonant frequency means FR equal to 1100 Hz provided. Find the value of K. And when you see the formula for low pass filter, R0 equal to root of L by C, which is equal to K. K oda value equal to R0. Constant K filter layum and m-derived filter layum R0 equal to K. This is the consideration. So in the question itself they provided impedance R0 equal to 400 ohm. Therefore R0 equal to K. So K value also, the answer is what? Same. That means 400. So this is the answer for the second question. Now the third question, the expression of M of the m-derived low pass filter, அதாவது m ஓட value low pass filter க்கு என்ன இருக்கும்? The options are m equal to root of 1 plus fc divided by f for the whole square, and m equal to root of 1 plus fc divided by f the whole square, and m equal to root of 1 minus fc divided by f for the whole square, and m equal to root of 1 minus fc divided by f the whole square. Actually I showed that formula, that is midpoint impedance m equal to, for a low pass filter, root of 1 minus fc divided by f infinitive the whole square, and the f infinitive is the infinite attenuation frequency. Okay, so sometimes they will give, நீங்க சில புக்ஸ்ல பார்க்கும்போது அந்த f infinityக்கு பதிலா they will use this notation, that is fr. Okay, so the answer is root of 1 minus fc divided by f for the whole square. Okay, this is the answer. Now the fourth question, the characteristics impedance will be uniform in the pass band when m-derived half section having dash is connected at the ends. I told you know, constant K filter la one of the disadvantage enna அப்படினா non-constant image impedance. So we have to get the uniform characteristics impedance in the pass band. Okay, so for that ஒரு half section, அதாவது for example இப்போ low pass filter அப்படின்னா first inductor, then the capacitor and inductor arm will come. So that's the half section. In that half section, what's the value of m? That's the question. So the options are m equal to 0.6, m equal to 0.9, and m equal to 0.8, and m equal to 0.1. So from the derivative version they already calculated, when m equal to 0.6 we will get this uniform characteristics impedance, அதாவது m ஓட value 0.6 உள்ள ஒரு arm நீங்க half section arm for transmitting and receiving end la connect பண்ணிட்டு in between we can connect the network. When you connect like that you will get uniform characteristics impedance. Okay, so the answer is m equal to 0.6. Okay, now the fifth question, advantage of m-derived filter section is option A sharp cutoff response, option B low cutoff response, option C constant image impedance, option D non-constant image impedance. I already told you m-derived filter la main ரெண்டு advantage தான் to overcome the constant K filter problem. One is non-constant image impedance problem avoid பண்ணி தான் என்ன கொண்டு வந்தாங்க, constant image impedance. But apart from that, one of the drawback is low cutoff response. Okay, so advantage of m-derived filter section is sharp cutoff response. This is the main advantage. sharp cutoff response we will get. So the answer is sharp cutoff response. Now the sixth question is the m-derived filter section is called as minima. M-derived filter section is called as mean, midpoint impedance, median, and mode. Okay, this m, no, what's the meaning of n? That's the meaning of min. Okay, so the answer for this question is midpoint impedance. Okay, now the seventh question is the low pass m-derived T section introduces an infinite attenuation pole at 2.05 MHz while the cutoff frequency is 2 MHz. The value of m is, see the question, in the question it's a low pass filter. Okay, now the options are option A, m equal to 0.42, then m equal to 0.63, then m equal to 0.21, then the options are m equal to 0.11, and it's a low pass filter. So the formula for m equal to root of 1 minus fc divided by f infinity the whole square, and fc value as well as f infinity values are provided in the question. Ninga adu direct potali you will get the answer, and the answer is 0.21, and I will show you the procedure. Now see this, m equal to root of 1 minus fc divided by f infinity to the whole square, which is equal to root of 1 minus 2 into 10 to the power 6 divided by 2.05 into 10 to the power 6 the whole square. So when you put it in the put all the values in the calculator, you will get m equal to 0.21. Now the eighth question, a low pass m-derived T section with m equal to 0.197, c equal to 1.27 nanofarad, and L equal to 3.18 microhenry. Find the value of inductor in the shunt arm. Okay, so inductor in the shunt arm. Okay, right, and this is the low pass filter. Okay, so low pass filter now first or inductor, then in the shunt arm or capacitor as well as one inductor will be there. Okay, so we have to find the value for that inductor. Okay, so the options are 3.87 microhenry and 4.60 microhenry and 3.43 microhenry and 4.23 microhenry, and I will show you the answer and the procedure. The answer is 3.87 microhenry. So in the low pass filter shunt arm, now see this, in the shunt arm this is the formula 1 minus m square divided by 4m into L. Okay, so when you put all the values in the formula, that is m value provided, L and C value provided, you will get inductor in shunt arm L equal to 3.87 microhenry. Now the ninth question, a high pass m-derived pi section network with m equal to 0.28 and C equal to 21.22 picofarad. Find the value of capacitor in the circuit. This is pi section network, it's a high pass network. Okay, so we have to find the value of the capacitor. அப்போ உங்களுக்கு அந்த pi section model diagram ஞாபகம் வரணும். Diagram ஞாபகம் வந்து automatically you can put the value, you can easily identify the answer. Okay, now the options are 72.67 picofarad and 76.78 picofarad. The third option is 74.67 picofarad and fourth option is 75.78 picofarad. And the answer and the procedure is, the answer is 75.78 picofarad. Now see this, in the high pass shunt arm, no, this is the formula C by M. Don't think that இங்க m ஓட வேல்யூ இருக்கு, கெபாசிட்டர் வேல்யூ இருக்கு, ஃபார்முலால C by M னு போட்டுருக்கு, ஆனா நம்ம வந்து கெபாசிட்டரோட வேல்யூ அப்படின்னு எடுத்துக்கிறோம். ஆக்சுவலி ஷண்ட் ஆர்ம்ல கெபாசிட்டரை C by M னு தான் ரெப்ரசன்ட் பண்ணணும். அப்போ இதுதான் ப்ரீவியஸ் எக்ஸாம்பிள்ல என்ன ப்ரீவியஸ் ப்ராப்ளம்ல inductor value கண்டுபிடிச்சோம். Okay, so whatever be the format available in the diagram, based on that you have to put the value. So it is equal to C by M. So C by M equal to 21.22 into 10 to the power minus 12 divided by 0.28. So you will get 75.78 picofarad. Now the last question, the relation between Z0 phi and Z0 phi dash in the circuit is shown below is. அதாவது கொஸ்டின்ல என்ன கொடுப்பாங்கன்னா இந்த மாதிரி ரெண்டு சர்க்யூட் கொடுப்பாங்க. ஓகே, இது பை மாடல். இங்கே ஃபர்ஸ்ட் மாடல் பாருங்கள், ஒரு சீரீஸ் ஆர்மில் Z1 இருக்குது, பேரலல் ஆர்மில் 2Z2 2Z. சிமிலர்லி இந்த செகண்ட் டயக்ராம் Z1 dash 2Z2 divided by M and 2Z2 divided by M. ஓகே, இது நார்மல் மாடல், திஸ் இஸ் த m-derived மாடல். ஓகே, ரைட். ஸோ த ரிலேஷன், இந்த ரெண்டோட ரிலேஷன் என்ன அப்படிங்கிறது தான் கொஸ்டின். Now see the options are Z0 pi equal to 2Z0 pi dash. Okay, the z0 pi equal to 4 z0 pi dash. Okay, now z0 pi equal to z0 pi dash, right? And z0 pi equal to 3 z0 pi dash, and the answer is z0 pi equal to z0 pi dash. The reason is, இங்க பாருங்க, இது வந்து ஒரு normal constant K filter section model. Okay, now this is the m-derived model. Okay, so basically when they are connecting these two network, the constant K filter drawback avoid பண்ணி impedance constant கொண்டு வரதுக்கு தான் they are utilizing this m parameter. Okay, so when they are choosing this kind of two network in the connectivity, and இந்த ரெண்டு மேட்ச் ஆகிற மாதிரி தான் they will design. So regarding that, don't think that இங்கே வந்து 2 ஆல மல்டிப்ளை ஆயிருக்கு 4 ஆல, so like that don't think that. Maybe it's a T model or maybe it's a pi model. Both circuits are same, like that the answer will come. Okay, then only we can transmit the signal without loss. So z0 pi equal to z0 pi dash. Okay, so main நீங்க ஞாபகம் வச்சுக்க வேண்டியது m-derived filterல one is the main advantage is what? The sharp cutoff response and the constant image impedance we will get when m equal to 0.6 is connected at both ends. Okay, so if you like this video, okay, kindly share my channel, and thank you so much for watching my video. Thank you.